Greenland is melting. And that sentence alone should terrify you. Not because of the ice, not because of the sea levels, but because of what happens underneath the water when that ice disappears. There is a current flowing through the Atlantic Ocean right now that controls the weather of entire continents, regulates monsoon systems that feed billions of people, and keeps Western Europe from turning into a frozen wasteland. Scientists call it the Atlantic Meridional Overturning Circulation. Most people have never heard of it. And Greenland, that enormous, frozen, supposedly distant island, holds the on-off switch. By the end of this video, you will never look at a world map the same way again. Here is the problem that nobody is talking about loudly enough. The Atlantic Ocean is not a passive body of water. It is a conveyor belt, a massive, planet-wide system of moving water that carries heat from the tropics all the way up to the North Atlantic, then sinks, cools, and flows back south along the ocean floor. This circulation system, sometimes called the AMOC, is essentially the engine behind the climate stability that human civilization was built upon. And Greenland's ice sheet, which contains enough fresh water to raise global sea levels by roughly 7 meters if it all melted, is slowly dumping that fresh water into the exact spot where this engine needs salt water to function. The implications are not just dramatic. They are genuinely civilization-altering. And in a moment, you will see exactly why the location of Greenland on the map is no accident in this story. Let's zoom out first, because to understand what is happening, you need to picture the ocean as a machine. Warm, salty water flows north from the tropics along the surface of the Atlantic. It releases heat into the atmosphere. This is why London, which sits at the same latitude as parts of Canada, has a climate mild enough to grow palm trees in some coastal areas. When that warm water reaches the waters near Greenland, Iceland, and the Norwegian Sea, it cools rapidly. Cold water is denser than warm water, and salt water is denser than fresh water. So this cooled, salty water sinks deep into the ocean, sometimes descending nearly 3 kilometers, and flows southward along the bottom of the Atlantic. This sinking is the engine. Without it, the whole conveyor shuts down. And what shuts down the sinking? Fresh water. Specifically, enormous quantities of cold fresh water pouring off the edge of a melting ice sheet directly into the region where the sinking is supposed to happen. Which brings us straight back to Greenland. Greenland's ice sheet is not just big. It is staggering in scale in a way that maps routinely distort beyond recognition. On a standard Mercator projection, the map most of us grew up with, Greenland appears roughly the same size as Africa, or even larger. In reality, Africa is about 14 times larger. The distortion makes Greenland look like a continental giant, when in truth it is enormous, but not that enormous. What is real, however, is the volume of ice sitting on top of it. Approximately 2.85 million cubic kilometers of frozen water, built up over hundreds of thousands of years. And this ice is melting at a rate that oceanographers describe, in research published over the past decade, as historically unprecedented in recorded measurement. Some studies suggest Greenland is losing ice at a pace roughly 6 times faster than it was in the 1990s. That is not a slow, distant process. That is happening now. And in a moment, you will see what the data from the ocean floor is already starting to show. If you enjoy these deep dives into maps, hidden geography, and the forces quietly reshaping the world, consider subscribing. There is a lot more where this comes from. Now, here is the part that most coverage gets completely wrong. The narrative around Greenland's melting usually focuses on sea level rise. And yes, that is real and serious. But the oceanographers who study the AMOC are not primarily worried about the water going up. They are worried about the water going in. Every year, Greenland releases hundreds of billions of tons of fresh water into the Labrador Sea and the waters south of Greenland. This fresh water does not sink. It floats on the surface, lighter than the salt water beneath it. And as it accumulates, it disrupts the density gradient that drives the sinking of cold water, which means it disrupts the engine. Multiple peer-reviewed studies, including work published in prominent scientific journals in recent years, have identified a measurable slowing of the AMOC over the past century. Some researchers argue the current is now at its weakest point in over 1,000 years. That is an extraordinary claim, and the debate in the scientific community is genuinely heated. But the trend across multiple independent datasets points in the same troubling direction. So what actually happens if the AMOC slows down dramatically, or, in a worst-case scenario, collapses? This is where the story gets genuinely wild. Europe loses its primary heat source, and temperature drops across the UK, Scandinavia, France, and Germany could be dramatic. Some models suggest winter temperatures in northwestern Europe could fall by 5 to 10 degrees Celsius over several decades. That does not sound catastrophic until you realize that the agricultural systems, infrastructure, energy grids, and urban planning of hundreds of millions of people were built around current climate norms. Meanwhile, the tropics and the southern hemisphere would actually warm faster, because the current that normally carries heat northward would no longer be doing so. The disruption to monsoon rainfall patterns in West Africa, the Amazon and South Asia, regions that depend on those rains to grow food for billions of people, could be severe. And in a moment, you will see why this is not a distant theoretical scenario, but something the geological record suggests has actually happened before. Here is the plot twist that changes everything. The AMOC has collapsed before, not because of human activity, not because of industrial emissions, but because of exactly the same mechanism playing out right now. Around 12,900 years ago, at the end of the last ice age, a massive glacial lake in North America, called Lake Agassiz, suddenly drained into the North Atlantic. The influx of fresh water shut down the AMOC almost instantly in geological terms, and the northern hemisphere was plunged back into near-glacial conditions for roughly 1,200 years. This event is called the Younger Dryas. It was not a gradual change. Sediment cores and ice cores from Greenland show the temperature shift happened within decades. Some researchers believe it may have happened within years. The planet went from warming to deep freeze, not because of a slow trend, but because a threshold was crossed. A tipping point was reached, and the source of disruption then was fresh water from melting ice pouring into the North Atlantic, which is, structurally, exactly what Greenland is doing right now, just more slowly and from a different angle. The scientific debate is not about whether the AMOC can collapse. The geological record confirms it can. The debate is about how close the current system is to a critical threshold, how much additional freshwater input it can absorb before the balance shifts irreversibly, and whether the warming of the ocean itself, which changes the temperature differentials that drive the circulation, compounds the freshwater problem into something faster and less predictable than the models currently show. Some researchers have proposed what they call early warning signals embedded in ocean temperature data, subtle statistical patterns that precede large-scale system transitions. Reports from multiple research groups suggest those signals may already be visible in Atlantic sea surface temperature anomalies. Others in the scientific community argue the models are not yet reliable enough to draw firm conclusions. But here is the uncomfortable reality. Nobody is arguing the system is getting stronger. Now, let's bring this back to Greenland itself. The island, the people, the place on the map that is sitting at the center of all of this. Roughly 56,000 people live on Greenland. The vast majority are Inuit, indigenous to the Arctic, with a culture and way of life built around ice, sea, and a landscape that is transforming beneath their feet. Fishing communities in places like Ilulissat, a town that sits beside one of the most active glacier outlets on Earth, have watched the ice retreat within living memory. The Ilulissat Ice Fjord, a UNESCO World Heritage Site, calves icebergs with a regularity and violence that has increased visibly over recent decades. Local fishermen and hunters describe changes in sea ice thickness, in the behavior of marine animals, in the predictability of seasons that their ancestors depended on with precision. The irony is almost unbearable. The people who have done the least to cause this crisis live at its literal epicenter and have the fewest resources to adapt to it. And then there is the geopolitical layer, which has its own kind of insanity. Greenland is an autonomous territory of Denmark, but the interest from outside powers, particularly the United States, has never been more visible. American military presence on Greenland dates back to World War II, and Thule Air Base in the northwest of the island remains a critical strategic installation. As Arctic sea ice retreats, new shipping routes through the Northwest Passage and across the top of the world become increasingly navigable, and Greenland sits at the edge of all of them. Greenland's subsoil also holds significant rare earth mineral deposits, resources that are strategically vital for electronics, renewable energy infrastructure, and military technology, and those deposits are becoming more accessible as the permafrost thaws. So, at the exact moment the island is contributing to a potential global climate catastrophe, it is also becoming more desirable, more strategic, and more contested than at any point in modern history. The ice is the crisis and the treasure map at the same time. Here is what this all means and why the perspective shift matters. When you look at a world map and see Greenland in the corner, oversized, cold, peripheral, you are seeing the wrong picture. Greenland is not peripheral. It is not distant. It is not simply a cold, uninhabited island somewhere near the top of the planet. It is the location where the Atlantic Ocean's circulatory engine either keeps running or shuts down. It is a repository of frozen water whose slow release is writing the next chapter of global climate history in real time. It is home to a living, complex, ancient culture that is navigating an existential transformation without having caused it. And it is the geopolitical prize of the coming century precisely because the warming that threatens the global climate system is simultaneously opening up what lies beneath. The ocean current that keeps your weather predictable, that drives the rains that grow your food, that has quietly underpinned human civilization for 12,000 years. Its future is being written right now in the meltwater flowing off Greenland's coast into the cold gray waters of the North Atlantic. That is not a metaphor. That is the mechanism. And understanding it changes not just how you see Greenland on a map, but how you understand the map of the world itself. If this video made you see something differently, drop a like. It genuinely helps this channel reach more people. Subscribe if you want to keep exploring how geography shapes everything we think we know. And leave a comment answering this question. Do you think Greenland will become more important in the next 50 years? Or do you think the world will act before it reaches that point? The link in the description has more on the AMOC research and the sources behind everything covered here. We will see you in the next one.